Okay, video number 3. Kind of wanted to show you if we took a region like the one we started with before, y equals x squared, like the one here, and we revolve it around something which is not necessarily the y-axis or the x-axis. This is going to be around some other vertical line out here. Want to show you what happens here. Watch the animation on this one. So as you can see, this thing goes way around this vertical axis right here. So the volume of this thing is going to be pretty big because of the fact it's going so far outside of this vertical axis. The biggest thing here is the axis of revolution is way out here. It's not the y-axis. Now, remember when I told you guys that functions are measured from the y and the x-axis out to the curve. The radius, however, is measured from here out to the curve. So we're going to have a difference between the function and the actual radius. You can see your representative slice in there. Um, Here's the inner circle and the outer circle. So the thing I want to kind of show you, and I don't want to touch this because it's going to rotate the whole thing, but the radius goes from here all the way out to this piece right here. That's your outside radius. The function, however, is measured from the y-axis. So you're going to have something from the y-axis, which is your function, plus that additional distance right there. That's the radius. And then the inner function will go from here to here, but the radius goes from here to here. So it's going to be whatever the inside function is plus that additional radius right there. So I kind of wanted to show you that. And then if it's on the other side, we might actually have to do some subtraction. So hopefully you guys have had a chance to get back to this here. Hopefully you guys have had a chance to try this problem. And this is where we're going to stop. There won't be anything after this example 5, but it's good to go through this so you can see what's going on. All right. So example 5, it's really the same exact functions. We're just going to do it around 4 different axes. So it says the region bounded by y equals 0, that's the x-axis, the graph of y equals square root of x, and x equals 4. So it's got to be bounded by all those things. It's going to be revolved around the x-axis, find the volume. So again, we'll just do a quick sketch. Okay, y equals the square root of x from here out to here. We'll call that 4. And we're going to take this region and we're going to revolve it around the x-axis. So on the other side, it's going to look something like this. And when you go ahead and revolve that thing, you're going to have a representative circle here. Now there's no inside radius, so it's just going to be circles, circles all the way from the left to the right. So we're going to go from 0 to 4. It's revolved around the x-axis, so it'll be dx because your change of circles goes this way. So 0 to 4, this is the volume of pi times the radius squared. Well, what's the radius going to be? Well, the radius goes from here to there. The radius is this function square root of x. Square root of x squared dx. All right, so the volume is going to be pi. That's going to be the square root of x squared, of course, is just x. The antiderivative of that is 1/2 x squared from 0 to 4. Plugging in 4, we're going to get pi times, what's that, 16 times a half, it's 8. And then minus 0. So really what we get is 8 pi. So this thing, this solid figure, it kind of looks like a bullet head or something, I don't know, has a volume of 8 pi. So now if we take exactly the same thing, same exact region, 0 to 4, but now we're going to revolve this thing around the y-axis. So now it's going to go around here. So it's going to look something like this. Again, it should be symmetric. And now I am going to have, in this case, I'm going to have washers. There's the inside radius, and then here, whoa, is, oh, that was horrible, is the outside radius. Try this again. That's really, really big, but you get the general idea. It's really hard to write on this tiny little tablet. So what we need is the radii. Outside radius goes all the way out to there. Inside radius goes to here and stops. So the outside radius is, well, this is just a distance because this is 4. The outside radius is 4. All the way up and down this thing is 4. Outside radius is 4 because it's a vertical line, 4. Inside radius is going to be defined by this. But remember now, since we're going around a vertical axis, we have to solve this for x. So solving that for x, squaring both sides, we get that x equals y squared. So from here out to this function right here is going to be y squared. So the inside radius is y squared. All right, so let's erase that. I don't like that. So this is going to be a volume of integral from, now we do have to figure this out going up to here. If I plug 4 in for x into this, I'm going to get out y is 2. So really this is the point 4, 2, which means I'm going to go from 0 up to y value of 2, because now we're doing this with respect to y since it's vertical. So 0 to 2, pi times my outside radius squared minus pi times the inside radius squared dy. All right, let's go ahead and take the pi out to the front. And then we're going to get an integral from 0 to 2 of 16 minus y to the 4th dy. So pi antiderivatives are going to be 16y minus 1/5 y to the 5th from 0 to 2. Not quite zeros and ones, but the 0 is going to be good. So let's see, plugging in 2, we're going to get pi times 2 times 16 is 32. 2 to the 5th, what is that? 2, 4, 8, 16, 32, so that's 32 fifths. And plugging in 0 goes away, so we just got to put everything in terms of fifths. Let's see, pi times 32 in terms of fifths, that's going to be whatever 32 times 5 is. What is that? 10, 1 is 160? 160, yeah, that's right. 160 fifths minus 32 fifths is going to be, what is that, 128 fifths, so 128 pi over 5. And that's the volume of revolving this thing around the y-axis. Definitely different than the volume of revolving it around the x-axis. Way bigger, I think, actually. Yeah, way bigger. Okay. Same region. This time we are revolving this thing around the line x equals 4. So this is where things will start to change. Here's 4. We're going to revolve it around this line. This is the line, vertical line, x equals 4. So we're going to revolve it around here, which means on the other side, it's going to look like that. So my representative circle here is going to look like this. Because here's the center, here's the axis of revolution, and my radius actually goes from here out to here. So this is the interesting part. This is the radius. But remember that a function is measured from here to here. And I am doing this revolving it around a vertical, so I'm going to solve this again for x. So x is going to equal y squared. So if you can kind of think of this, the total distance here to the axis of revolution is 4 units. This, however, this little blue line right here, heading from the y-axis out to the function, that's y squared. So make that a little bit thinner. This is y squared. So that means the radius from here to here is actually the difference of these two. This is 4, this is y squared, so the radius, which is the difference from here to here, is actually going to be 4 minus y squared. Right, that's the hardest part about doing these, is when we start changing these axes of revolution to try and figure out this radius. If you can get the radius, the rest of it's usually not too bad. So there's the radius. Now we can integrate. Still going vertically, so it's going to be 0 up to 2. That's what we had last time. So the volume will be the integral, 0 to 2, pi times my radius squared, dy. All right, we're going to have to FOIL that thing, so we bring this over here. Volume equals pi, integral 0 to 2. Foiling that's going to give us, what, 16 minus 8y squared plus y to the 4th dy. Antiderivative, so pi 16y, what is that, 8/3 y cubed plus 1/5 y to the 5th from 0 to 2. All right, so here, that's a 16. So if we plug in 2, we're going to get pi times 32. Let's see, 2 cubed is 8. 8 times 8, 64/3 plus, again, that was 32, right? So 32/5. This is going to be kind of a big fraction here. Everything's got to be in terms of 15ths, it looks like. Ooh, nasty. Okay, so pi times 32 times 15. Oh man. 32 times 10 plus 5. So that's a 480, I think. 480 over 15. Numbers usually aren't quite that big. Let's see, 64 times 5 is going to be 20, carry the 2, 30, 320? Yeah, that sounds right. And then 32 is multiplied by 3, so that's going to be plus 96. 15, so that's a 96. So let's see, 480 minus 320 is going to be 160 plus 96 is 256/15 pi. Ooh, that's nasty. But there you go. That's the volume if you take it and revolve it around this this thing right here. 256 over 15 pi. Double check that just to make sure, but I'm pretty sure that's right. Let's make that look like a 6. Trying to anyway. There, that's better. All right, last one. Taking this region, same exact region, and we're going to take that region, and this time, what are we revolving this around? X equals 6, so it's even further out. So here it is from 0 to 4. Now my vertical line is the line x equals 6. I'm really having a hard time drawing 6s. So this thing is going to be way out here, something like that. Whew, it's going to be huge. Representative circles, in this case, you have an inside radius, and we have an outside radius. Something like that. So the inside radius is going to go from here to here, or from here to here. It doesn't really matter which direction. Well, if this is 6 and that's 4, the inside radius, that should be easy. That's going to be 2. It's going to be constant because it's a vertical line here and here. So the inside radius, what's going on here? My computer's acting up. So the inside radius is 2. The outside radius goes from here all the way out to here. But remember, the function is defined from here to here. So the total distance from here to here is 6. This is the function, y squared. So this outer radius here is going to be the difference between 6 and y squared. So the big radius here is 6 minus y squared. And then we should be able to go ahead and do the integral here. So the integral, again, it's vertical, so it's going to go from 0 to 2. So the volume will be integral from 0 to 2, pi times the outer radius squared minus pi times the inner radius, which is 2 squared, and it's dy. All right, let's see what we get. Volume will be pi. So this we have to FOIL. So that'll be 36. Wait, 6 is just not working. Minus 12y squared plus y to the 4th minus squaring that one, that's just 4 dy. So I can combine 36 and minus 4. We're going to get 32 minus 12y squared plus y to the 4th dy. And now let's take an antiderivative. So we're going to get pi times 32y minus, what is that, 4y cubed plus 1/5 y to the 5th, evaluated from 0 to 2. Fortunately, I think we're only going to have to deal with fifths here, which is okay. So let's see, pi times 2 times 32 is 64. 2 cubed is 8 times 4 is 32 plus 32 fifths. And again, plugging 0 in makes everything go away. That's nice. So 64 minus 32 is 32 plus 32 fifths pi. And 32 in terms of fifths, we already worked that one out earlier, was 160 over 5 plus 32 over 5. So we should end up with a volume of 192 fifths pi. And it's a good thing that I am done because my computer is really lagging behind right now. All right, that's it. This is as far as we are going to go. The rest of this stuff is stuff that we will do. The rest of this stuff is stuff that we're going to do in class. So this is as far as you guys need to go. There we go. And I hope that maybe you guys could figure some of those out. If not, there you go. Sorry the videos are so long, but there you have it.